Alright, there's a video for one VT and one HT about exercise 29. This is about the braking distance for a vehicle. Because if you're driving in a vehicle, you need to brake. It takes some space to completely come to a standstill. And with this formula, D equals 0.005 times V squared, you can calculate the braking distance. And D stands for the braking distance in meters. So how many meters you need to come to a standstill, and V is the speed or the velocity in kilometers per hour. Alright, so we need to use this formula. On this paper here, I'll just write down the formula. It was D was 0.005 times V squared. So now we can use it. The first question is, calculate the braking distance for a speed of 60 kilometers and for 120 kilometers. Alright, so what if the velocity or the speed is 60 kilometers per hour? Alright, you're going to take the 60 and we're going to fill that in over there. So then you get, as a braking distance, you get 0.005 times 60 squared. Now this is how you type that into your calculator. We do 0.005 and then times and then 60 squared. Squared was over there, remember? And then we have 18. So if you're driving 60, you need 18 meters to brake. Okay? And if the velocity is 120 kilometers per hour, then we'll need a different amount of meters. Let's calculate what we have then. So now we have 0.005 times 120 squared. Now if I type that in, I will get, let me see, 72 meters. Okay, so you need a lot more space to come to a standstill. But this was exercise A. Let's see what exercise B asks of us. It says that Berend, he makes a statement. He says, if you drive twice as fast, then your braking distance is 2 times longer. Is he correct? Why or why not? Well, he is not correct, because you see the braking distance is actually 4 times as big. So Berend is wrong. The distance is 4 times as big. It says as big here outside of the screen, instead of 2 times as big, because he says only twice as big. Well, he's wrong about that. Then the next question is about Jasmila, and she drives into a stopped car. The braking room was 14.7 meters. Jamila says she was only driving 55 kilometers per hour. Is that true? Why or why not? Yeah, so she bumped into another car, and she said she was only driving 55 kilometers per hour. So if you fill in 55 kilometers per hour, right, let's fill that in. So we get as a braking distance 0.005 times 55 squared. And then let's see what we get. I'll type it into the calculator that I have over here. This is 15 point so many meters. So this is what you need as a distance to be able to brake. But here the braking room was 17.6 meters. So that means that if she was driving 55, she would have enough room to brake. But she didn't, because she hit the other car. So is this true? No, that's not true. It's not true. It's not true. Yeah. So actually, she was driving a bit faster. If you actually want to know how fast she was driving, this is extra for students that want to learn like something extra. So we know that the braking room that she had was 16.7. That's the space she needed to brake. So or maybe she was even driving faster than that. But now I want to know, what was the velocity? So what was this V, so that the outcome will be that? I'll tell you how you can solve this. You can first get rid of this 0.005 here by doing this number divided by 0.005. I'm going to do that. I'm going to do 16.7 divided by 0.005. And that is 3,340. And like I already said, this is extra. This is actually something that you're going to learn next year, right? But maybe you can already understand it. So first I divide this by that number and I divide that by that number. So V squared is this. Now if I want to know what V is then I have to use the square root of this number. So let's take the square root. The square root you can find over there, over here. So square root off, and then 3340, and then is this, it's 57.8. So she was driving at least 57.8 kilometers, maybe even faster, right? So this is the this is how you calculate that. So thank you for watching, and I'll see you later. Bye bye.